All right, in this video, we're going to talk about, we're going to keep working that stoichiometry, but this time we're going, instead of going from mole to mole, you'll notice I've recopied our diagram from the previous videos at the top of the page. This time, instead of going from mole to mole, we're going to go from mole to mass. Yeah, we're going to start with moles, we're going to mass, or we're going to go from mass to mole, but we're going to go here, starting here to here, or here to here. And you'll notice this time we said with these diagrams, every time we cross a bridge, that's a conversion factor. And in this case, we're going to be crossing two bridges. So we're going to use two conversion factors, not just one. Before we go too deep down this rabbit hole, let's review molar mass. If you remember, for molar mass, if you're an element, for example, carbon, your molar mass would be 1 mole carbon is 12 grams of carbon. And if you don't remember this, go back and watch the video on molar mass. Molar mass is very important. If you're a compound, like for example, water, the molar mass is the sum of the masses of each individual atom. So oxygen is 16 and hydrogen is 1. So we would have 16, 17, 18. So the molar mass for water is 1 mole of water is 18 grams. Similarly, if we were going to do methane, carbon is 12 and hydrogen is 4. So we would have 12, 13, 14, 15, 16. I would have 1 mole of CH4 is 16 grams CH4. And remember, it's always grams in 1 mole or 1 mole to the grams. Sometimes people will get confused and put 16 moles in 1 gram. The mole portion is always 1. It's always 1 mole. Great, let's take a look at this problem now, going through the steps that we laid out in the last video. Coal can be converted to methane gas by a process called coal gasification. The unbalanced equation for the reaction is the following. So let's balance this. I've got 2 carbon on my right, so I want 2 carbon over here. I've got 4 hydrogen, so I'm going to put a 2 here. That's going to give me 4 hydrogen, 2 oxygen, 2 oxygen. This is a 1, and that's a 1. So now I'm balanced. And that was the first step, right? And in this case, the equation was written for us, but I had to go ahead and I had to balance it. So step 1, write and balance the equations. Step 2 is to frame up the problem. What mass in grams? So here's my question word. What mass in grams? What mass of grams in carbon? So over here, I'm going to have mass of carbon, and that's going to be grams of carbon. Is required to react with water to form 1 mole of methane. Now they mention water, but they don't give us an amount. They say I'm starting with 1 mole of methane. So this is where I'm starting from. So I have 1 mole CH4, and I'm going to put that over 1. We want to label, the next step is to label what I'm starting with in green. So I'm starting with moles. Of methane, and I'm going to put moles of A, and I'm going to mass my stop point in red is here. Can you do that? Can we go from the right to the left? Sure, we can compare any 2 compounds or any 2 elements in a chemical equation with stoichiometry. So when we're making a comparison, it doesn't matter. They could both be the reactants. They could both be the products. I could go from here to here. I could go from here to here. Doesn't matter at all. The next step is to use my diagram to figure out which conversion factors I need. So I'm starting with moles of A here, and I'm going to the mass of B here. So this is the problem that I need to work out. That means that I'm going to need, my first conversion factor is going to be the mole ratio, and my second conversion factor is going to be that molar mass of compound B, which is carbon. So I already wrote that one out. I have that right there. The other conversion factor, though, that I need is the mole ratio between A and B. That's going to be 1 mole of CH4 to 2 moles of carbon. Or I could write that as 2 moles of carbon to 1 mole CH4. And then my other one is 1 mole carbon to 12 grams of carbon, 12 grams of carbon to 1 mole of carbon. So these are my 2 conversion factors, and I've written them out both ways. Now I need to insert my conversion factors. I have moles. So the first thing I need to do is I need to go from moles of A to moles of B. So I'm going to use my mole ratios here. And I need methane, CH4, to be on the bottom. So this one's not going to work. So I'm going to put in 2 moles of carbon to 1 mole CH4. Then I'm going to need, I got from here to here. Now I need to go to mass of B. I need my molar mass. I've got moles of carbon on the top, so I need moles of carbon on the bottom. That one's not going to work. 12 grams of carbon to 1 mole of carbon. And now I need to cancel my units to make sure I set this up correctly. So starting here, I've got moles of CH4, moles of carbon cancels. Multiply and divide, 12 times 2 is 24. So if I start with 1 mole of methane, I can make, or if I want to make 1 mole of methane, I'm going to need to start with 24 grams of carbon. Did my multiplication and division. Again, same thing we did in the last video, we're just expanding the direction we're going. Okay, I've got a practice problem for you to try. Let me slide my paper. So go ahead and pause the video, see how far you can get on this. All right, welcome back. How'd you do? Okay, again, they've written out the equation. We don't know if it's balanced. Actually, I think it might be. So we have got, nope, it's not. I've got 4 oxygen, and I've got sorry about that pause. My tape was a little beat up there. I changed that out. I swapped out my tape. Okay, so I've got 1 sulfur. That's good. I've got 2 hydrogen, but look at my oxygen. I've got 1, 2, 3, 4, 5, and over here I've got 4. So I know I'm going to have to even that up. I'm going to put a 2 there, and that makes me need a 2. I've got now I need 4 hydrogen, so I need a 2 there. And I've got 2 sulfur, so I'm going to need a 2 there. So let's do a count. I've got 4 hydrogen, 2 sulfur, 2 sulfur. I've got 2. This is going to be 6, 3, 4, 5, 6, 7, 8 oxygen, and I have 8 oxygen. So there's a 1 here. So now I'm balanced. Okay, frame up the problem comes next. Sulfur dioxide is an unwelcome result of burning soft coal in power plants. Some of the SO2 ends up as sulfuric acid in acid precipitation. We really didn't need to know any of that. Here we go. What mass in grams? So what I'm solving for, the question word, put that in red, of SO2. So I'm solving for grams of SO2 is needed to react with 37.5 moles of O2. So this is what I'm starting with. So over here, I'm going to put 37.5 moles of O2, and I'm going to put that over 1. Now I want to label in my equation what I'm starting with. This is my starting, and I'm starting with moles. Moles of A, and I'm going to mass of B. Whoops. Force of habit. And here's a good example of we're comparing 2 of the reactants. So let me grab so I'm going from moles of A to mass of B. Should have taped this down. So if I come back up here, it's the same thing I did before where I'm going to need the mole ratio and I'm going to need the molar mass of B. Now in the homework, sometimes you're going to start with mass and you're going to end up here. And that's okay, because now we're using these. I should probably do another video that has a sample on it, but. Okay, so mole ratio between these two is 1 mole of O2 to 2 moles of SO2, 2 moles of SO2 to 1 mole of O2. And molar mass of B, I'm going to have 1 mole of SO2. I'm going to have 32 as the mass of sulfur, plus 16 plus 16 is going to be 64 grams. I'm going to write that both ways. Now I need to insert my conversion factors. My diagram tells me that mole ratio comes first. I need O2 on the bottom, so I'm going to use this one. 2 moles SO2 over 1 mole of O2. Now I need my molar mass. And I've got moles on the top, so I need moles on the bottom. So I'm going to use this one. 64 grams of SO2 over 1 mole of SO2. Cancel my units. Moles of O2 cancels. Moles of SO2 cancels. 64 times 37.5 times 2 is going to be 4,800 grams of SO2. Okay, in the next video, we're going to go mass to mass. So we're going to go the whole diagram next time around. All right, that's it for now.